June 6, 1944, midnight, 6 Horsa gliders towed by Halifax bombers crossed the English Channel toward Nazi-occupied France. Inside each wooden aircraft sat 30 British paratroopers and 2 pilots navigating by moonlight toward a target the size of a football field. Their objective: capture Pegasus Bridge intact before German forces could blow it. The gliders, constructed entirely from plywood by furniture manufacturers, had to land within 50 yards of the bridge, miss by more than that, and the element of surprise would be lost. At precisely 0016, the tow ropes released. The gliders descended in silence towards the Caen Canal, each pilot fighting to maintain control of 70 feet of wood and fabric carrying 15,000 pounds of men and equipment. Major John Howard's glider touched down 90 yards from the bridge, the most accurate combat glider landing of the war. Within 10 minutes, his men had seized the bridge. The wooden aircraft built by furniture makers in Birmingham and High Wycombe had delivered British airborne forces exactly where they needed to be, when they needed to be there. This is the story of how Britain sent tanks into battle inside wooden gliders, and how furniture craftsmen became essential to winning the war. The problem began in 1940. Germany had demonstrated the devastating effectiveness of airborne assault during the invasions of Belgium and France. Glider-borne troops had captured Fort Eben-Emael, considered impregnable, in minutes. They'd seized strategic bridges before defenders could react. The British War Office watched these operations with a mixture of admiration and alarm. If Britain was going to establish credible airborne forces, it needed gliders, large gliders. Gliders capable of delivering not just infantry, but vehicles, artillery, and eventually tanks. The problem was industrial capacity. Aircraft manufacturers were operating at absolute maximum output, producing fighters and bombers. There was no spare capacity for gliders. RAF expansion had consumed every available aircraft engineer, every precision machinist, every facility capable of working in aluminium and steel. Building gliders in traditional aircraft factories would mean reducing production of Spitfires, Hurricanes, and Lancasters, an unacceptable trade-off when Britain was fighting for survival. The solution came from an unexpected realization. Gliders didn't need to be built like aircraft. They required no engines, no complex fuel systems, no electrical generators, no navigation equipment. A glider was fundamentally a large wooden box with wings, and Britain possessed thousands of craftsmen who specialized in building large wooden boxes. Furniture manufacturers, companies like Harris Liebus, one of Britain's largest furniture makers, could construct wooden structures to precise specifications. They employed thousands of workers skilled in woodworking, joining, and finishing. Their factories contained the equipment needed for mass woodwork: saws, lathes, joining machinery, finishing facilities. In December 1940, the Air Ministry issued Specification X.26/40 for a large assault glider. Airspeed Limited, a small aircraft manufacturer, received the contract. But from the beginning, the design philosophy was revolutionary. Build it from wood, design it for furniture makers, break it into sub-assemblies that could be manufactured separately and assembled elsewhere. The glider would never be a precision aircraft. It would be a utilitarian transport built to tolerances furniture makers could achieve, designed to be assembled by RAF maintenance units rather than aircraft factories. Designer Hessel Tiltman deliberately kept the design simple. The Horsa, named after the 5th century Saxon king, would use wooden construction throughout: 3-ply timber for the fuselage skin, spruce and ash for the frame members, plywood for control surfaces. The fuselage was divided into 3 sections: nose compartment with pilot positions, cargo section capable of holding 28 fully equipped troops or a jeep and gun, tail section supporting the control surfaces. The sections bolted together using standard fasteners. No welding, no riveting, no specialized aircraft assembly techniques. The first prototype flew in September 1941, 11 months after the specification was issued. The glider performed beautifully. It was stable, controllable, and surprisingly robust for a wooden aircraft. Tiltman later said the design went from drawing board to air in 10 months, which was not too bad considering the drawings had to be made suitable for the furniture trade, who were responsible for all production. That last phrase was key. Suitable for the furniture trade, every design decision prioritized ease of manufacturing by non-aircraft workers. Production began in early 1942, and the contract distribution revealed the radical nature of the program. Airspeed's factory in Christchurch built the first 695 gliders, establishing production standards. After that, furniture manufacturers took over. Harris Liebus, Austin Motors, and dozens of smaller contractors received orders for glider components. These companies had never built aircraft. Many had never worked to aircraft tolerances, but they understood wood, they understood joints and fasteners, and they understood how to build strong structures from plywood and timber. The Horsa was broken into 30 separate sub-assemblies. A furniture factory in Birmingham might manufacture wing sections. Another in High Wycombe produced fuselage panels. A third built tail assemblies. Each component was built to standard dimensions, marked and shipped to RAF maintenance units, facilities at airfields across Britain where the final assembly occurred. This decentralized production served multiple purposes. It distributed risk. German bombing couldn't destroy Horsa production by hitting a single factory. It preserved precious industrial capacity for weapons requiring precision engineering. And it was fast. A furniture factory could tool up and start producing Horsa components within weeks. The human cost of this decision was immediately apparent. Furniture craftsmen weren't aircraft workers. They didn't understand aeronautical loads, stress concentrations, or fatigue limits. Quality control was inconsistent. Some sub-assemblies arrived at maintenance units with joints that didn't quite align. Others showed variations in dimensions that required shimming during final assembly. The RAF maintenance crews performing final assembly became experts at compensating for manufacturing variations, adding reinforcement here, adjusting alignment there, ensuring each glider met minimum flight standards even if components weren't perfectly matched. This wasn't precision engineering, it was expedient engineering. But it worked. By mid-1942, Horsas were being produced at rates no traditional aircraft factory could match. The program eventually delivered over 3,800 gliders by 1945. Production spread across dozens of facilities, employing workers who'd never touched an aircraft before the war. Compare that to bomber production. A Lancaster required 18 months and consumed resources equivalent to building 60 Horsas. But the Horsa's real innovation wasn't just its construction, it was its size. At 77 feet long with a 67-foot wingspan, the Horsa was massive by glider standards. Its cargo capacity dwarfed anything previously built. The standard load was 28 fully equipped paratroopers, but the versatility became apparent immediately. Remove the troops, and the Horsa could carry a jeep or a 6-pounder anti-tank gun with its towing vehicle and crew, or ammunition pallets, or medical supplies, or eventually, in the Mk2 version, vehicles driven directly through a hinged nose section. The Mk2 represented the program's evolution. Introduced in 1943, it featured a reinforced floor, a hinged nose that swung open for vehicle loading, twin nose wheels for ground maneuvering, and an increased weight capacity. The furniture makers who'd struggled with the MKI's manufacturing tolerances had learned. The MK2 showed better quality control, more consistent dimensions, and improved structural strength. The workers who'd been building bedroom sets 2 years earlier had become glider manufacturers. Operationally, the Horsa was expendable by design. These weren't aircraft intended for repeated use. They were single-mission transports. After landing, the glider was abandoned. The tail section could be jettisoned by removing 4 bolts, creating a rear exit for rapid troop deployment. If the nose section needed opening, that too could be accomplished quickly. The glider's value wasn't in the aircraft itself, it was in delivering cargo to locations where no powered aircraft could safely operate. The first operational use came in November 1942 during Operation Freshman, an attack on German heavy water production in Norway. 2 Horsas were towed by Halifax bombers. Both gliders crashed in mountainous terrain during severe weather. The operation failed catastrophically, but it provided brutal lessons about glider operations in adverse conditions. The wooden aircraft were stronger than expected. Both gliders remained largely intact despite violent crashes. The problem was navigation and weather, not structural integrity. Sicily, in July 1943, offered a second test. Operation Husky involved large-scale glider operations delivering British airborne forces. Results were mixed. Some gliders released too early, ditching in the Mediterranean. Others landed scattered across Sicily, far from intended drop zones. But those that reached their objectives delivered troops exactly as designed. The glider's ability to land troops together rather than dispersed like paratroopers proved tactically valuable. An infantry platoon arriving concentrated could achieve objectives impossible for scattered parachutists. D-Day demonstrated the Horsa's full potential. Operation Tonga involved landing the British 6th Airborne Division east of the invasion beaches to secure the flanks. The assault required over 300 Horsa gliders and 34 larger Hamilcar gliders, massive aircraft also built by furniture makers capable of carrying light tanks. The Pegasus Bridge operation became legendary. 6 Horsas, piloted by glider pilots of the 6th Airborne Division, landed within yards of the bridge in darkness. Major Howard's men captured the bridge intact within minutes, preventing German forces from using it to counterattack the invasion beaches. The precision was remarkable. Glider pilots had no engines, no ability to correct errors. Once the tow rope released, they descended on a ballistic trajectory adjusted only by control surfaces. Landing at night, using only moonlight for reference, hitting a target measuring hundreds of yards while descending at 100 miles per hour required extraordinary skill. The fact that 3 of 6 gliders landed within 100 yards of the bridge represented navigation and flying far beyond what most observers thought wooden gliders could achieve. But Pegasus Bridge was infantry assault. The Hamilcar gliders demonstrated something even more audacious, delivering tanks. These enormous gliders, also wooden, also built largely by furniture manufacturers, could carry a 7-ton Tetrarch light tank or 2 universal carriers. On D-Day evening, 30 Hamilcar gliders landed in Normandy, carrying tanks of the 6th Airborne Armoured Reconnaissance Regiment. The operation was chaotic. 1 Tetrarch broke loose during flight, crashed through the glider's nose, and both fell into the channel. 2 gliders collided on landing, destroying the tanks they carried. A third flipped a Tetrarch while unloading, but 17 Tetrarchs reached their assembly area and immediately provided armored reconnaissance. The sight was surreal, light tanks rolling out of wooden aircraft in fields behind German lines, providing fire support to paratroopers within hours of landing. The Tetrarchs were outclassed by German armor, but their presence provided psychological impact far exceeding their combat value. German commanders facing airborne troops expected infantry and light weapons. Encountering tanks, even light tanks, forced them to commit heavier units and divert resources. The cost differential with traditional methods was staggering. Delivering a battalion of infantry by sea required transport ships, naval escorts, landing craft, and beachhead facilities. The entire apparatus of amphibious assault, supported by naval gunfire and air cover, delivering that same battalion by glider, required only tow aircraft, bombers already in service, performing double duty. The gliders themselves were expendable. A Horsa cost roughly the same as a Jeep, perhaps £2,000 in 1944 currency. Losing 50 gliders in an operation represented £100,000 in write-offs, trivial compared to losing a single destroyer Operation Market Garden in September 1944 deployed gliders on an unprecedented scale. The plan called for capturing bridges in Holland, creating a corridor into Germany. Over 2,000 gliders, including hundreds of Horsas, delivered the British 1st Airborne Division to Arnhem. The operation failed strategically. German forces prevented the capture of Arnhem Bridge, but the gliders performed as designed. They delivered troops, jeeps, ammunition, and supplies directly to landing zones miles behind German lines. The failure was operational planning, not glider capability. The final major glider operation came in March 1945 during Operation Varsity, the Rhine crossing. Over 400 gliders, including both Horsas and Hamilcars, landed on the east bank of the Rhine in daylight. A departure from previous night operations, the casualty rate was severe. German anti-aircraft fire destroyed numerous gliders in flight and on landing, but the operation succeeded. The concentrated delivery of airborne forces directly into the battle zone overwhelmed German defences. Within hours, the bridgehead was secure and ground forces were crossing the Rhine. By war's end, Horsas had participated in every major British airborne operation. They delivered over 50,000 troops into combat, along with thousands of tons of vehicles, weapons and supplies. The wooden gliders built by furniture makers had proven capable of missions conventional wisdom said required precision aircraft. More importantly, they'd been available when needed. The 3,800 Horsas built represented industrial capacity that simply didn't exist in traditional aircraft manufacturing. The post-war accounting revealed the program's efficiency. Building 3,800 Horsas consumed roughly the same industrial resources as building 200 medium bombers. But those 200 bombers flying combat missions would have been steadily depleted by losses. The gliders were one-use aircraft by design. Each glider built represented guaranteed delivery capability. The aircraft would deliver its cargo once certainly, then be abandoned. There was elegance in this economics. No maintenance, no spare parts, no repair facilities. Just build them, use them, and build more. The furniture manufacturers emerged from the war with capabilities they'd never imagined. Harris Liebus, which had built bedroom furniture in 1939, had manufactured precision aircraft components by 1945. The skills transferred to post-war production. Furniture makers who understood aircraft tolerances built better furniture. Some companies continued in aviation, applying woodworking expertise to aircraft interiors and components. Others returned to furniture, bringing wartime quality control standards to peacetime production. Most Horsas were scrapped after the war. The gliders had no peacetime purpose. A few survived as farm buildings, their fuselages converted to storage sheds or chicken coops. One nearly complete Horsa Mach 2 survives at the Museum of Army Flying at Middle Wallop. A full-size replica stands at Pegasus Bridge in Normandy, unveiled in 2004 for the 60th anniversary of D-Day, with Prince Charles sitting in the cockpit alongside Jim Walwork, the pilot who'd landed there 60 years earlier. The Horsa's legacy wasn't technological innovation. The glider was deliberately low-tech. The legacy was industrial adaptation. When Britain needed thousands of aircraft but lacked aircraft manufacturing capacity, it discovered that furniture makers could build adequate substitutes. The gliders weren't elegant. They weren't precision instruments. They were plywood boxes with wings built by craftsmen who'd been making chairs and tables months earlier, and they worked. The tanks delivered by glider on D-Day tell the complete story. A Tetrarch light tank cost £10,000. The Hamilcar glider delivering it cost perhaps £5,000. The Halifax bomber towing it cost £50,000. Total investment per tank delivered £65,000, but that tank arrived behind German lines within hours of the invasion, providing armoured support exactly where conventional logistics couldn't reach for days. The wooden glider built by furniture makers had solved a problem steel and precision engineering couldn't solve economically. June 6, 1944, midnight. 6 wooden gliders cross the channel toward Pegasus Bridge. The pilots aren't professional aviators, they're army officers trained in glider flight. The aircraft aren't precision machines, they're plywood structures built by furniture makers. The mission requires landing 70 feet of wooden aircraft within yards of a target in darkness. It succeeds. Within 10 minutes, British troops control the bridge. By dawn, the wooden gliders have accomplished what conventional assault would have taken days to achieve. At a fraction of the cost, the Horsa glider program built 3,800 aircraft using industrial capacity that otherwise would have sat idle. It delivered over 50,000 troops into combat when no other method could have placed them there. It cost roughly £7.5 million total, less than 3 destroyers, less than a dozen strategic bombers. And it fundamentally changed how wars could be fought. Furniture makers built wooden gliders. Those gliders carried tanks into battle, and Britain won the war.